Hello everyone. So today we will be doing a teaching demonstration about the 4 A's in lesson plan. My name is Jarek John Laguipo. I am from BSED Mathematics and I am a first year student. So without further ado, let us start the teaching demonstration. Good morning everyone. So who will be doing today's prayer? Anyone? Okay, good morning class. Now, before we start our demonstration, we need to start doing the attendances. Now that we have completed the attendance, let us formally begin our discussion. So today, we are going to be talking about permutations. We are going to start on the third unit of Mathematics 10. And our objective is to determine whether a counting-related problem can be solved through the use of permutation. The second one is to explain how permutations can be utilized and applied in real life. And finally, perform derivations of how n and r are correlated to the formula of permutation. So before we actually start to the lesson, we need to ask you, the students, about what your prior knowledge is or what your first impression of this current lesson. So my first question is, regarding to your previous topic, which is about circles, or the last term of your second quarter, can you accurately relate them to this current topic, which is about probability? Number 2, what are your first impressions to the introduction to probability? And number 3, what do you mathematically think about permutations? Now, if anyone can have the volunteer to answer me one of these questions, please raise your hands. Anyone? Now that we know your first impressions of probability, specifically permutations, we are now going to conduct an activity in which we can warm up and pump up our brains so that you will be prepared for the discussion that we're going to do today. So, I want everyone to participate or just get a scratch paper. If you do know the answer to this question, you may raise your hand, but I will be picking one person to randomly answer. There are no wrong answers because everyone can solve and everyone can attempt to answer the questions that I'm going to present. So, to start off, my first question is, a close friend invited Anna to her birthday party. Anna has 3 new blouses, stripes with rifles, long sleeve, and sleeveless. And she also has 3 skirts, which are red, pink, and black, in her closet, reserved for such occasions. Now, the problem is, assuming that any skirt can be paired with any blouse, in how many ways can Anna select her outfit? Number 2, how many blouse and skirt pairs are possible? Now, anyone can participate. You can raise your hand. I will not randomly pick, but if you do have the answer, you can raise your hand. Now, your answer is correct. Yes, you have the correct answer. Now, let's have the second question, which is, suppose you secured your bike using a combination lock. Later, you realize that you forgot the 4-digit combination. You only remembered that the code contains the digit 1, 3, 4, and 7. Now, the questions are, list all the possible codes out of the given digits. Number 2 is, how many possible codes are there? Number 3, what can you say about the list you made? Like, as always, anyone can answer. If you do have the answer to one of these questions, you can raise your hand and try to volunteer in front of the blackboard. Anyone? Now that we have completed the activity, let us give ourselves a round of applause for having a vast prior knowledge on our topic. So, now we are going to formally start our discussion about permutations. So, to begin our topic, what is permutations? Are you familiar with this word? Do you know what this word is in mathematics? So let me tell you, permutation is basically called an ordered combination. So for example, you have a locker with 99 combinations and only 3 numbers are possible. Now, you cannot open a lock. You cannot open it unless you do it on an exact order. Okay? That's how it works. And if you are familiar with combination, it is completely different from permutation. Combination is a type of sequence in which that it can be the same whether it's on a different arrangement. For example, 1, 2, 1, 3, 4, 5, 7, it's still correct. It's still a combination. But on permutation, you cannot do that. You have to arrange it on a specific group or a different type of format. It could be chronological, it could be numerical, or has a pattern in which it follows. That's how permutations work. So, for this example, the word permutation is not the same with the word totain rumet, because, like I said, it is not a scrambled word. It has to be arranged. It has to be arranged in order to form the word. That's how permutation is. It can be considered, the other word can be considered as a combination if it could be a word or it cannot be a word. As long as it's scrambled or it's arranged, it does not matter. It has an indefinite order. So that's how combinations work. Now, the formula for permutation is basically P, or permutation, of NR is equal to n factorial all over the quantity of n minus r factorial. So, let me break it down to you. N means the number of sets in the problem. So for example, you have 5 people and you're going to arrange them into 3. So your n is 5. Okay? So what about the 3? The 3 is R. What is R? The R is the selected arranged group. So basically, the number of selected elements to be arranged. So for, like I said, if you have 5 people to be arranged into 3, so meaning n is 5 and R is 3. And what is this exclamation point that you're seeing? In mathematical term, that means the factorial, or multiplying its consecutive negative number. So for example, 5 factorial, that means 5 times 4 times 3 times 2 times 1. It stops at 1 because we all know the rule of multiplication. When you go down to 0, everything goes down to 0. The product is 0. So 5, 4, 3, 2, 1. You just multiply them. So like the example that I given, the example here is in how many ways can 5 students arrange themselves for a photo. Now, we all know that there are 5 students, so that's n. Okay? Now, we need to understand how many ways can they be arranged. It is said that 5 students arrange themselves. So it is self-explanatory that R should be equals to 5. Now that we know that both n and R are 5, we can now use the formula of permutation. So we have 5 factorial equals 5 minus 5 factorial. So we have 5 factorial divided by 0 factorial. So since 0 factorial is 1, so the product of 5 factorial is the number of combinations that the students can arrange themselves in an orderly manner. So that means 120 possibilities that the students can arrange themselves. Now, I know what you're thinking. Sir, what if we did permutation on objects or words that have duplicate numbers or duplicate amounts? Would that ruin permutation? Because the arrangement can duplicate. It can ruin the number of permutated possibilities. Well, yes. However, we have this another technique called distinguished permutation. Now, distinguished permutation is basically a special type of permutation that's only used for words or objects that duplicate each other. So this means that every duplicate are grouped into how many amounts of duplicate that element has. So for example, we use that on the word statistics. So statistics has many duplicate letters. So we have the S, the T, and the I. So we have 3 S, we have 3 T's, and 2 I's. Now, since statistics is a 10 word, we can use a different formula. Okay? So, given on this formula right here, it states P equals N factorial all over P factorial, Q factorial, and R factorial. Now, you will ask that, sir, why is there P, Q, R? It makes it very confusing. Well, yes, it does make it confusing. However, I'm gonna break it down to you. P, Q, and R are variables that can be changed over time. It depends on how many duplicates you have on an object, a group, or a word. So, we have P, Q, and R. It can be dependent. Now, we have statistics. So we have 3 sets of duplicate letters. We have S, T, and I. Therefore, we can solve the distinguished permutation, which is based on the formula, which is 10 factorial all over 3 factorial times 2 factorial times 3 factorial. So, if you multiply all of the factorials at the top, the numerator and the denominator, you will get 50,400 permutated possibilities. That means that you can make an arranged words or arranged possibilities. You can make 50,400 possibilities of creating a word or an arrangement of letters from the 10-word letter statistics. Now, before I start publishing or stating the applications or what we are going to do later, anyone has further questions or violent reactions about our topic, or anyone? Now, since anyone doesn't have any question, I want to ask one of you to give us a bit of a generalization or a summary of what you have learned in this discussion. It's a very small summary. It's completely fine. You can just give a very small lesson summary of the lesson, and at least in your own experience, how can permutation be used in real life? Anyone? Now that we know a student's perception in permutation, now let's move on to application. Now, in application, I want you guys to divide the house into 2 groups. These 2 groups will be separated and be labeled as the analyst and the audience. Now, sir, what's the audience and the analyst? It's very confusing. Now, let me tell you first. The point of this kit is that we will be doing a lottery scenery or a dramatized simulation of how permutation can be used in real life situations, and the very best example there is lottery. Now, I will give you the entire time, not the entire time actually. I will give you like 20 minutes because we are running short on time. Then after that, we can start assessing it and we can start performing it right now. So go! Okay, so very good output, everyone. Let's give ourselves a round of applause. Now that we've learned that the application of permutation is very applicable to lotteries or anything that's related to probabilities or numbers of outcomes, we are now prepared for an evaluation time. We are now prepared for your assessment. It's a formative assessment worth 10 items. I want you guys to bring 1 yellow paper so that we can start doing the evaluation. Okay, so we are already out of time. Now, we have to check this tomorrow. But in case, I will show you guys the assignment. You have to pass this tomorrow. It's only just 3 questions, and it's very easy if you already know how computations of permutations work. So, thank you everyone. That concludes my discussion. Thank you everyone for giving me this opportunity to teach you about permutations. Let's meet again tomorrow. Goodbye, class. Now that I have completed the teaching demo and the 4 A's, which is activity, analysis, abstraction, and application, I have to do this reflection video. So, what I reflect from this teaching demo is that I, as a student, a teacher's student, I was able to discover how teaching demos work, and how the lesson plan and the matrix that I've made it very easy and accessible for me to get on the flow with informations that I am about to present to the students. So, because of this teaching demo, I was able to do a consistent demo about how I can put the activities and how I can review them to the students, because I have already given a plan for it. I have already constructed a design in which such formative assessments can be used after the application stage, and therefore, because of the lesson planning and because of this teaching demo, I was able to make the lesson plan concrete, or make it as dramatized as possible for me. And as a teacher student, this was a huge knowledge for me to have an experience about teaching. That is all. Thank you.